Welcome. I'm Steve Banwart. I'm director of the Global Food and Environment Institute. I'm a professor, and I hold a leadership chair in integrated soil, agriculture, water research at the University of Leeds. This talk on smart agriculture was prepared jointly with my colleague, Professor Lisa Collins, who leads the Institute's strategic research program on smart agri-systems and is also head of the School of Biology at the University of Leeds. This presentation was first given live online on the 20th of April 2020 at a University of Leeds Alumni Association event titled Meet the Researchers. In addition to the presentation, at the end, I'm going to answer some of the questions that were put to me that day by the online participants. Today, I'm going to lay out a series of challenges for global food supply in the 21st century. And I'm going to provide a positive vision for the future and a pathway to navigate through these challenges. The 4 decades from 2010 to 2050 was described in 2010 by the then chief scientist for the UK government as a perfect storm of converging global demands for natural resources, including those that support food supplies. These challenges were a human population that is anticipated to reach 10 billion by 2050 with growth in wealth and resource demands. There will be a quadrupling in the global economy with intense urbanization to 75% of the population in cities by mid-century. There will be a doubling in the demand for food and fuel, a more than 50% demand in the increase for clean water, a demand for productive land that is 10 to 45% greater than Earth's environmental capacity. All of this will have to be achieved while navigating the need to mitigate and to adapt to the impacts of a changing climate. I want to say that humanity will navigate this storm, and we will pass through to the other side. But this poses difficult questions. What is the path forward? What are the costs? What does our landing place look like on the other side of 2050? A forward glimpse of a positive outcome is starting to come into view. This includes a food system that delivers nutrition and health, not just calories, farming methods that restore soil, water, and biodiversity as well as supply food, carbon neutral circular agriculture, and food supply chains that recover resources, novel methods of farming that adapt to and help reverse climate change impacts. Food supplies will be restorative, reversing historical declines in rural population, livelihoods, dietary health, and environmental quality. The University of Leeds is facing these challenges with determination, a sense of urgency, and the confidence to step onto the world stage and provide leadership. We are a global university based in a rich agricultural region. We have the strength and diversity of talent on campus for new knowledge and invention that is based here, but with the potential for a positive influence and a market share worldwide. This creates both regional and global opportunity to strengthen farm value beyond the currently stagnant average income for UK farms, to diversify crops, novel plant protein sources that would improve farm incomes in the face of flatlining global commodity prices, to improve farming efficiency, to reduce pressure on extending agricultural land into marginally productive land, for example, into the Amazon basin, thereby protecting natural habitats and biodiversity. The potential for improved crop genetics to reduce the demand for irrigation water and mineral fertilizer that come with high carbon emissions from pumping water, from manufacturing mineral nitrogen, from mining rock phosphate and potash. The opportunity to improve efficiency, to reduce chemical application rates, and thereby reduce pollution, to reduce farming greenhouse gas emissions, and protect farming from future climate change. The opportunity to engage a circular economy that recycles organic nutrients from farm waste and urban wastewater and mineral nutrients from mining and construction waste back to land, thereby reducing mineral fertilizer demand, replacing soil organic matter that sequesters carbon from greenhouse gas emissions, and regenerating soil fertility. To achieve this, the University of Leeds draws on the Global Food and Environment Institute, to provide academic leadership that focuses research and innovation priorities and draws together the necessary teams to collaborate on solutions. We have a strong vision from the university's senior executive team and from academic leaders that translates this into strategy and delivery that drives success. We have great academic strength. We're ranked first in the UK for agriculture, forestry, and food, the current Guardian League tables. We are joint 11th in global ranking to deliver impact in meeting the United Nations Sustainable Development Goals. We are top 15 in the world for earth and marine sciences, top 20 in geography, and top 50 in environmental science. There is substantial new investment in the Global Food and Environment Institute. Most importantly, funding from our faculties for new academic staff that are working together. Our 350-hectare commercial University of Leeds farm hosts the National Pig Research Center and is being developed into a globally unique combination of strengths and is defining what food and farming supply must look like in 2050 and beyond, providing complete nutrition, net zero emissions, no waste, and capturing the full value of farming. We want to show you how we are achieving this. The University of Leeds Research Farm hosts the National Pig Research Center. It is funded as part of the UK Agritech Centre for Innovation and Excellence in Livestock, CL. The university is providing a £12 million capital investment in state-of-the-art facilities for livestock research. The Nigel Bertram Visitor Centre is built to welcome guests to the site and host conferences, workshops, and meetings. CL anchors the site-wide development of the university farm as an agricultural teaching, research, and commercial innovation facility. The University of Leeds is a national leader in pig nutrition research. This is through the work of Professor Helen Miller, who founded the National Pig Research Center as part of CL. The Pig Sustain project, led by Professor Lisa Collins, develops and tests technology to enable the transition to sustainable livestock production. This includes digital technology to precision monitor the pig herd and to adjust production conditions such as inside environment and diet. It includes connection to digital supply chain tracking to follow the food supply from the point of production on the farm through processing and distribution to the point of retail, and to add value by accounting for high standards of animal welfare and environmental benefits. This new research is considering the circular economy and how to gain energy and nutrients from animal waste and to help close the loop towards carbon neutral agriculture. Professor Collins also leads the Climate Pig Project, pilot research that examines the impacts of changing climate on outdoor livestock production. This includes applying precision tracking of pigs to adapt animal welfare, health, and energy conversion efficiency to reduce the impacts of extreme weather in outdoor livestock production. It also includes monitoring soil and water impacts of extreme weather, such as the influence of storms on manure runoff from fields into streams and groundwater aquifers, and managing rotations to retain nutrients in soil and prevent pollution emissions to water bodies. The university is providing a £3 million capital investment in environmental observing instrumentation and digital technology to track environmental fluctuations and link this to on-farm decisions. For weather forecasting, we use a widely distributed network of atmospheric and land surface sensors that produce data streams for real-time forecasts of weather. We are transforming these methods to include satellite imaging over a surface, monitoring soil and groundwater conditions, tracking atmospheric chemistry, and crop responses. We will be able to forecast the influence of environmental fluctuations on crop growth, guiding agrochemical applications and testing practices that reduce cost overheads and cut pollution. We aim to push the boundaries of digital technology with control systems and robotics, including autonomous vehicles for field work to till, plant, tend, and harvest, and to manage livestock. With these advances in tracking of conditions and operations on the ground, together with forecasting methods and greater automation, we will produce more and healthier food on less land with less chemicals, reduce environmental emissions, lower risk from climate change, and create far greater farm value. As an example of current technology, the worldwide weather forecasting system that draws on this type of technology with distributed sensors around the globe to predict whether on short and longer timescales, is an example of the way that we can start to use much greater digital technology and innovation on the ground within farms to do exactly that type of thing for the entire food supply and extend forecasting into how the environment behaves in soil and water and for crops and animal production. Fundamental biology is harnessed to maximize the genetic potential of new crops to aid the transition to the future farm of 2050. This innovation at the biological level will address the complex challenges of improving genetics in fluctuating environmental conditions and variable agricultural management regimes. All of these must be developed together and cannot be addressed in isolation. It improves water and soil nutrient use efficiency of crops to adapt farming to future conditions of lower rainfall, to help reduce inputs of fertilizer and expand the range of crops available to farmers to produce new food ingredients for human consumption. It targets the nutritional value of crops and maximizes the content of specific types of plant fiber, oil content, or as new sources of plant milk for human consumption. Future crops will enable industrial collaboration on gene-edited crops together with testing at the University of Farm to debug innovation under commercial farming conditions. Through this work, we will enable greater diversity of crops and income streams, reduce chemical inputs to farming, and improve the nutritional value of food. The capital investment in digital observing systems enables the University of Leeds Farm to be developed as a digitally connected smart farm. Observing systems track environmental conditions of the atmosphere, vegetation, soil, drainage streams, and groundwater. It will be able to link these to precision monitoring of livestock and tracking of farm practices. This information will feed into supply chain tracking technology. These data streams will be able to guide farming decisions and business planning through the supply chain. This offers a platform to support farming and food education and research, from undergraduate education programs through master's and doctoral training, academic research, and partnership with industry for commercial innovation and testing. We are excited to have the opportunity to develop this capability within the rich agricultural production region of Yorkshire and the north of England. We see opportunities to innovate locally and to lead globally. The Global Food and Environment Institute works worldwide. We have major global partnerships in Africa, East Asia, and the Americas. Here are two examples. AfriCap is an £8 million project to future-proof African agriculture and food supply to climate change. It is funded by the Global Challenges Research Fund of the UK's National Research Council. It is a major program which draws on the UK's international aid budget to help the world's poorest regions through innovation. We are helping reshape fertilizer use in China. It has double the application rate in Europe, which is causing enormous greenhouse gas emissions from nitrous oxide and from the energy demand and carbon footprint of mineral fertilizer production. It is also causing loss of fertilizers, pollution to rivers, and groundwater drinking supplies. To prevent environmental and human health risks and to meet international obligations to reduce greenhouse gas emissions, we work with key partners in China on research to replace mineral fertilizer with organic fertilizer from agriculture and urban waste streams. The University of Leeds is tackling major global challenges and creating solutions that will enable transformations not only in Yorkshire and the UK, but worldwide. This is the final slide of my presentation. I hope that we have given you a glimpse of a positive future and some examples of the pathways forward. Our aim at the University of Leeds and the Global Food and Environment Institute is to transform the future by hot-housing creativity and through transformative, collaborative education programs. Thank you all for joining me today.